Good day, everyone. Today, we are going to talk about classifying functions from graphs and equations. Before we begin, let's think about some situations that we encounter in real life. For example, imagine a taxi fare that increases at a constant rate. Or consider the distance of a person from a particular point as that person moves away and then comes back. We can also think about the path of a ball thrown into the air. There are also real-world relationships that may follow square root or cube root patterns. Notice that these situations don't all behave in exactly the same way. So here's our question. How can we determine which type of function is appropriate for each situation? That's what we are going to explore today. We want to be able to look at a mathematical relationship and recognize the type of function that can represent it. By the end of this lesson, you should be able to identify common types of functions from their equations. You should also be able to recognize the characteristic shapes of their graphs. More specifically, we will distinguish 5 function types: linear, absolute value, quadratic, square root, and cube root. You should also be able to classify a function using either its equation or its graph. And finally, you should be able to explain what features helped you identify the function. Before we classify functions, let's quickly recall what a function is. A function is a relation in which each input has exactly one output. Functions can be represented in several ways. We can represent them using equations, tables, graphs, or ordered pairs. For today's lesson, however, we are going to focus mainly on equations and graphs. Our goal is not simply to identify whether something is a function. We want to determine what type of function it is. Here are the 5 function types that we will study today. First, we have the linear function, whose parent function is f of x equals x. Its characteristic graph is a straight line. Next is the absolute value function, whose parent function is f of x equals the absolute value of x. Its graph has a characteristic v-shape. Then we have the quadratic function, with parent function f of x equals x squared. Its graph is a parabola. The fourth is the square root function, with parent function f of x equals the square root of x. Its graph is a curved branch that begins at an endpoint. And finally, we have the cube root function, with parent function f of x equals the cube root of x. Its graph has an S-shaped curve. These 5 parent functions will serve as our basic references. As we move through the lesson, remember these characteristic shapes because they will help us recognize the function families. Now let's look at the graphs side by side. Notice how different their shapes are. The linear function produces a straight line. The absolute value function produces a V. The quadratic function produces a U-shaped parabola. The square root function starts at an endpoint and curves in one direction. And the cube root function has an S-shaped curve and extends in both directions. These shapes are important because when we are given a graph without an equation, the shape can give us an important clue about the function type. So we can identify a function in 2 ways. We can look at its equation, or we can look at its graph. And ideally, the equation and the graph should tell us the same story. Let's begin with the linear function. A linear function is a function whose graph is a straight line and whose rate of change is constant. Its parent function is f of x equals x. The general form of a linear function is f of x equals mx plus b. Here, m represents the slope, while b represents the y-intercept. For example, we have f of x equals 2x plus 3. This is still a linear function even though it doesn't look exactly like the parent function f of x equals x. The important clue is that it is a first-degree polynomial, and its graph is a straight line. So when you see a first-degree polynomial or a straight-line graph, think linear function. Next, let's look at the absolute value function. An absolute value function contains an absolute value expression and has a characteristic V-shaped graph. Its parent function is f of x equals the absolute value of x. The general form is f of x equals a times the absolute value of x minus h, plus k. Here, the absolute value expression identifies the function family. The other parts can change the position, direction, or steepness of the graph. For example, f of x equals the absolute value of x minus 2 plus 1. This graph is no longer centered at the origin like the parent function, but it is still an absolute value function. So the important classification clue is the absolute value expression, and graphically, we expect a V-shape. Now let's look at the quadratic function. A quadratic function is a second-degree polynomial whose graph is a parabola. Its parent function is f of x equals x squared. Its general form is f of x equals ax squared plus bx plus c, where is not equal to 0. For example, f of x equals x squared minus 4x plus 3. Even though this graph is shifted from the parent parabola, it is still quadratic. So when identifying a quadratic function from an equation, one important clue is the presence of an x squared term as the highest degree. When identifying it from a graph, look for the characteristic parabolic shape. Next is the square root function. A square root function contains a variable inside a square root expression. Its parent function is f of x equals the square root of x. The general form is f of x equals a times the square root of x minus h, plus k. For example, f of x equals the square root of x minus 2, plus 1. Notice that the graph begins at an endpoint and then extends in one direction. That endpoint is an important visual clue. So when you see a square root expression in the equation, or a curved graph that begins at an endpoint, think square root function. Finally, we have the cube root function. A cube root function contains a variable inside a cube root expression. Its parent function is f of x equals the cube root of x. Its general form is f of x equals a times the cube root of x minus h, plus k. For example, f of x equals the cube root of x minus 2, plus 1. Unlike the square root function, the cube root graph extends in both directions. It has the characteristic S-shaped curve. So when we see a cube root expression or an S-shaped graph extending in both directions, that gives us a strong clue that we are dealing with a cube root function. Let's put everything together. We now have two important ways of identifying these functions. First, we can examine their mathematical form. For example, mx plus b suggests linear, while an absolute value expression suggests absolute value. An x squared term suggests quadratic. A square root expression suggests square root, and a cube root expression suggests cube root. Second, we can examine the graph. Straight line, linear. V-shape, absolute value. Parabola, quadratic. Curved branch with an endpoint, square root. S-shaped curve, cube root. So if you are given an equation, look for its mathematical structure. If you are given a graph, look for its characteristic shape. And if you are given both, use one to confirm the other. Now we need to make an important distinction. A function does not have to look exactly like its parent function to belong to the same family. For example, y equals x and y equals 3x plus 2 do not have exactly the same graph, but both are linear functions. Likewise, y equals x squared and y equals negative, open parenthesis x minus 2, close parenthesis squared, plus 4, look different, but both are quadratic functions. And y equals the square root of x and y equals the square root of x minus 3, plus 2, look different because the second graph has been shifted, but both are square root functions. So don't classify a function merely by asking, does it look exactly like the parent function? Instead, ask, what function family does this equation or graph belong to? Transformations can change the appearance or position of a graph without changing its function family. Let's summarize what we have learned. First, functions can be classified using their equations and/or graphs. Linear functions have the form mx plus b and have straight line graphs. Absolute value functions have the form a times the absolute value of x minus h, plus k, and have V-shaped graphs. Quadratic functions have the form ax squared plus bx plus c and have parabolic graphs. Square root functions have the form a times the square root of x minus h, plus k, and have a curved branch with an endpoint. Cube root functions have the form a times the cube root of x minus h, plus k, and have S-shaped graphs. And finally, transformations can change the position, direction, or size of a graph without changing its function family. So the main idea is this. The equation tells us about the mathematical structure, while the graph gives us a visual representation of that structure. Together, they help us classify functions. Before we finish, let's connect this lesson to the real world. We have learned that different function families have different mathematical structures and graph shapes. But why does that matter outside mathematics? Think about situations in business, social science, or nature. For example, a business may have a relationship between price, sales, cost, or profit. In social science, we may study population or other measurable trends. In science, we may study motion, growth, or other natural phenomena. These relationships don't necessarily follow the same pattern. So if we can identify the type of function that best describes the relationship, we have a better basis for choosing a mathematical model. Remember, when you encounter a function, don't just look at the numbers. Look at its mathematical form and its graphical characteristics. Thank you.